Hello everyone. Wanted to make a video for you on transformations of logarithmic graphs. So again, let's head up in class. We covered the graphs of our basic logarithmic functions. So these are what logarithm graphs look like. Again, logs are the inverse functions of exponentials. So the way that we graphed these, log base 2 of x is the inverse of 2 to the x power. And so we took our ordered pairs from up here with y equals 2 to the x. We took these ordered pairs and we switched x and y because that's what inverse functions do. And when we switched our x's and y's, we got these points right here, put them on our graph, and we can see that this is an exponential function on its side. Same thing with log base 1, half of x. Again, switched our x's and y's from our ordered pairs from y equals 1/2 to the x power. Put those on our graph, connected them, and again, we have an exponential function on its side. So this is what log graphs look like. And so now we'll go ahead and look at transformations of these guys. The transformations of these are going to be eerily similar to the transformations of the exponential graphs as well. And again, we're going to lean on a lot of our previous training from transforming all of our back pocket functions way back in, I want to say homework 5 or 6. So it's been a little while, so we'll try to refresh your memory here. But the only transformations we'll have are possibly a negative out here. It could be a positive or it could be a negative. If it's a positive, it won't affect our graph at all. If it's a negative, we'll have a transformation. We can also add or subtract a number inside our logarithm with x, and we might add or subtract a number outside of our logarithm function out here. Now, again, we're going to lean on our previous training and we'll figure out what each one of these does. So let's start with that plus or minus out front. If it's a plus, we're not even going to write it and we won't have any transformations there. But if we have a negative out front there, then we are going to have a reflection because it's a negative. And because it's outside of our log function out front, that means it's going to be a vertical reflection. So we're going to reflect this up and down over the x-axis. All right. Our next transformation that we'll go over is the plus or minus h here. If we add or subtract a number inside our logarithm with x, adding and subtracting numbers inside our function slide us left and right. And these move the opposite way you think they will. So if we have a negative h, if we're subtracting a number inside, that's actually going to shift us to the right by h units. And if we add that number h inside with x, this is going to shift us to the left by h units. All right, and then the last thing is this adding or subtracting a k value outside. Again, adding or subtracting a number outside our function is a vertical change, and this is going to move the way you think it is. So if we add k to the outside, that is going to shift our whole graph up by k units. And if we have a minus k out there, that is going to shift our graph down by k units. All right. A couple of notes to make here. The first thing that I want to kind of make note of is logarithmic functions, my basic logarithm functions, had a vertical asymptote at x equals 0. If we reflect our graph up or down, that won't affect our vertical asymptote. If we shift our whole graph up and down, that's not going to affect our vertical asymptote. But if we take the whole graph and shift it to the left or shift it to the right, our vertical asymptote is going to move with the graph. So I just want to make a note here that the vertical asymptote will shift right or left with your graph. So if you move your whole graph to the right 2 units, then your vertical asymptote will go from x equals 0 to x equals 2. It's going to shift with your graph. And the last note that I want to make here is remember that order matters. If we do these in different orders, we're going to get different graphs sometimes. So we're going to make sure we do these in the right order. First thing that you're going to do is horizontal shifting. So you will shift your graph to the left and right first. And then after you do your horizontal shifting, you will do any reflections that you may have. And the last thing that you're going to do is that vertical shifting. That should be the last thing that you do. So you will shift your graph up and down last. As long as you do it in that order, you'll be good to go. All right, so let's try this. Got some examples here where I've got some log graphs. The first thing that I want to do is just kind of look at what we have and list the transformations in the order that we would perform them. So notice in all of these, I have log base 2, log base 2, log base 2, and log base 2. And all of these functions are base, right? The function that's going to create the shape of this graph is y equals log base 2 of x. This is going to give us the shape of our graph. And we graphed this on a, right up here, log base 2. That was up here. Here we go. Log base 2 of x is right here. So notice that 1/2 -1, 1, 0, and 2, 1 are points on our graph. So I'm just going to use that. So we had 1/2 -1, 1, 0, and 2, 1. Those were points on our graph. So this is what y equals log base 2 of x looks like. And we have a vertical asymptote here at x equals 0. Okay, so this is going to be the overall shape of my graph. And then in each of these, let's figure out what our transformations will be. All right, so number 1 here, log base 2 of x minus 2. The transformation that I have here is this minus 2 inside with x. Because I'm adding or subtracting inside, this is going to shift me left and right, and it's going to go the opposite way that I think it will. So this is actually going to move us to the right by 2 units. And that's the only transformation we have here. So I'll just list that here, that this is going to move to the right by 2 units. And notice when I move this whole graph to the right by 2 units, my horizontal asymptote, sorry, not horizontal, vertical asymptote, just kidding. Words are hard. My vertical asymptote will also move to the right by 2 units, which means it's going to move from x equals 0 to x equals 2. All right, next one, number 2. What if we have log base 2 of x and I subtract a 2 on the outside of my function? Well, subtracting a 2 from the outside of my function is going to move us vertically instead of horizontally. And this is going to move the way that we think it will. So this is going to push us down 2 units. And that is the only transformation that we have here. So I will just list that one. And we would move the whole graph down 2 units. And notice moving everything down by 2 does not affect that vertical asymptote. It stays put. All right, number 3, 1 minus log base 2 of x. This is one where our brain is going to have a harder time um, figuring out our transformations from this format. I'm going to move things around so that my log comes first, and any numbers that are added or subtracted, I'm going to move to the right side of the log. So I'm just going to reorder this a little bit, and notice my log is negative. This -1 is attached to the log. It's going to stay with it. So I'm going to say this is negative log base 2 of x. And I'm adding 1 to that because that 1 is positive. I'm adding 1 to it. My brain's going to have a much better time figuring out transformations from this guy than from the way that it was originally written. Okay, so now that I've reorganized, let's figure out what these transformations are. This negative out front, what's that going to do? Yep, that's going to reflect us up and down. And then the only other transformation I have is this +1 on the outside. And because I'm adding to the outside, that's going to be a vertical shift, and it's going to move up 1. So now, which order do I have to do these things in? Well, first of all, I would shift left and right. I would do my horizontal shifting, but I don't have any of those. And so the first thing that I have that I'm going to do is I'm going to reflect this thing vertically up and down across the x-axis. And then the second thing that I'm going to do is move this vertically up 1. And notice the vertical reflection and the vertical shifting does not affect my vertical asymptote, so it's going to stay exactly where it is. All right. And then the last one we have is number 4, log base 2 of x plus 5 plus 3. I've got the +5, that's going to do a transformation, and the +3 is also going to be a transformation. So the +5, since I'm adding inside with x, going to shift us left and right, and it's going to go the opposite way you think it will. So adding 5 will move us to the left by 5 units. And then adding that 3 on the outside is going to move us up 3 units. And then which order am I going to do these in? First thing we have to do is our horizontal shifting. So I'm going to go left 5 units first. And then the last thing that I'm going to do is move this thing up 3 units. Are either of these things going to affect my vertical asymptote? Yes, the shifting left and right will move my vertical asymptote. So my vertical asymptote is going to go left 5 units with my graph, which means it's going to go from x equals 0 to x equals -5. Okay. So now let's try to practice this and actually transform one of these guys. So I want to graph log base 2 of x plus 5 plus 3. This is the last example that we just did here. So I know my base is going to be y equals log base 2 of x. I'm going to shift that first to the left by 5 units and then up by 3 units. And I know that my vertical asymptote is going to slide left 5 units with the graph. Okay, so I'm going to start. So this left one here will be my scratch work, and my right one here will be my final answer. So I'm going to start over here on the left, and I'm going to plot my base graph y equals log base 2 of x, which is this guy that I have up here. So we are going to have 1/2 -1, 1 0, and 2 1. Those are going to be points on my graph. And I'll go ahead and fill that in along with my vertical asymptote here at x equals 0. Okay, so this is my original graph, right? My base function. And then the first thing that I'm going to do here is slide this thing to the left by 5 units. And then after I slide it left 5, I'm going to move that thing up 3 units. Okay, those are all the transformations. So let's start by moving this whole thing to the left by 5 units. So I'm going to take each one of my points and go to the left. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. And this is where my vertical asymptote is going to shift to the left along with my graph. So my vertical asymptote is going to be over here at x equals -5. And then I'll fill my graph in. It's going to do one of these. Okay. So I moved this whole thing to the left by 5 units. And the last thing that I have to do here is take that green one and move everything up 3 units. So I'll move up 1, 2, 3. I'll move up 1, 2, 3, and up 1, 2, 3. And here is my final graph. So I'll move everything over here onto my final graph. I'm at -3, 4. I'm at -4, 3. And I'm at -4.5, 2. Okay. And my vertical asymptote shifted over here to x equals -5. Okay, and that is my final transformed logarithm graph. Okay, I hope that helps with the transforming exponential and log graphs. Again, start with our base log or exponential graphs, and then just perform the operations and lean on our previous training to do this. So let me know if you have any questions, and I will see you next time.